All right, so this is going to be the sixth review for the stats final here. This is going to be about binomial and Poisson distribution. So uh, there's a few types of distributions that we've looked at, right? We have the normal distribution, which is the bell curve, the z-score, all that. And these next two are kind of two different types of normal distributions. We have a binomial distribution, so binomial, which means that, again, we have one of two outcomes. I should say one of. So one of two outcomes. We have a P and a Q and so on and so forth. So remember, P is the chance of success, Q is the chance of failure. And again, this is like flipping a coin or picking a boy or a girl, something like that. Something that has two outcomes, one or the other. Don't have to be equally likely, like flipping a coin and boy or a girl are equally likely, but it has to be one of two outcomes only. For a Poisson distribution, and I'm going to spell this wrong here, so forgive me. Okay. I think that's spelled wrong. We don't know. So for a Poisson distribution, there are still only two outcomes, but this is tracked over a period of time or distance, whereas binomials tracked over a set number of tries. And again, we'll get to that difference here later on. But let's make sure we kind of know the general idea of both of these here first, okay? So for a binomial, you have four values that you usually track. You have n, which is the total number of trials. You have p, which is the percent of a win, I'll say a success or a win, and q is the percent of failure, and then x is the value that you're tracking. Okay, so how many successes or wins you want. So I should say, instead of saying value, let me say number of wins. Okay, so if you know these four values, you kind of know a binomial distribution. So using these four values, how do you figure out the average or the mean? Well, the mean of a binomial distribution is just NP. That's the average. Number of trials times times the percent of success. That's it. Which again makes sense. Let's say you have a 70% chance of making a basket and you try 10 times. Well, what's the average number of baskets that you think you'll make? Well, 10 tries, you're going to make about 70% of them. That's what you're assuming. Therefore, it's 7. So NP is how you get the average. To get the standard deviation, it's going to be root NPQ. So standard deviation is you multiply NPQ together, and then you take the square root. And if you want to figure out the probability of getting a certain amount of wins or losses or up or down, then we had two types of problems. We had a PDF problem and a CDF problem. And the CDF kind of had two different versions of it as well. So it's kind of what we mean there. So in your calculator, there's a function called binom PDF. And this is a process that will get you the exactly the probability of a certain amount of wins. So if you want the probability of getting exactly 5 baskets, or the probability of getting exactly 3 heads after flipping a coin 20 times, something like that, then you use binomial PDF. You get exactly a certain amount of successes. Whereas if you use binomial CDF, that will give you the probability of getting less than or equal to a certain number of successes. Equal to a certain number of successes. So let's say you want the probability of getting 5 or fewer baskets. Then you use binomial CDF. But it's always less than, not more than. It's always less than. Okay, just remember that. And so both these functions require you to know your NP and X. We actually don't use Q when you're using on the calculator. So let's go ahead and look at what forms these problems can take here. So a basketball player makes 80% of their free throws. They have 8 free throws to shoot. What's the probability they make 5 of them? So let's make sure that we can identify our NP and X first. So in this case, my N is 8 because he's going to make 8 tries. My P is 80%, so 0.8, because the chance of him making it is 80%. My Q is 0.2 because if there's an 80% chance to make it, that means there's a 20% chance not to make it, right? This is just simply 1 minus 0.8. That's how I get 0.2. And then X here is the 5. X is the number of successes I want to track. In this case, 5 makes, right? I want to figure out what's the chance that he makes 5 of them. Now, on average, what would I expect it to make? Well, if there's an 80% chance that he makes his basket, and he's going to make 8 attempts, well, that's just going to be 0.8 times 80, which is, or 0.8 times 8, which is going to be 6.4, right? Let me make sure I check that real quick. Yeah. So I expect him on average to make 6.4 baskets, which is not too far off from his target amount, right? What's the deviation? What's going to be root 8 times P times Q. Okay? So you take the square root of 8 times 0.8 times 0.2, and we get 1.13. Right? So that's the standard deviation. So this is kind of like breaking down the problem. We take a complex word problem and we break it down into its numerical components. Now, in order to use NP or NP and X, in order to use binomial PDF and binomial CDF, we're going to be using these three values here. Okay, these three are our core values when using our um, uh, stuff here. Okay, N, P, and X. Those are the three that we want to focus on. So, once again, we'll take the same situation. A basketball player makes 80% of their free throws, and they're going to shoot 8 times. What's the probability they will make exactly 6 shots? Okay, well, exactly 6 means it's a PDF problem, right? So it's going to be a binomial PDF. Now, again, depending on your calculator, you might put this in differently. But again, we need to put in our 3 values. So I'm going to get my calculator out here. So, it's found under, if you don't remember, it's distribution, so second vars. We want a binomial PDF, which is right here, about the 10th option down or so. And let's see here. We're going to shoot 8 times. We have an 80% chance to make it, and we want to make 5 shots. So that tells us it's about a 15% chance. Now, just to note that, again, it has to be done in this order. If I switch the 8 and the 5, for instance, let's say I put the 5 here and the 8 here, then it's going to give me 0, because if you only try 5 times, the chance that you're going to get 8 wins is 0, because you can't get more wins than you have tries. So it goes N, P, X. That's how you write it in the calculator. N first, then P, then X. So N, P, X. Otherwise, again, if you flip values, you're going to get the wrong answer. And so again, that was a 0.146, I believe, right? If I'm looking at this correctly here, we'll say 147. So 0.147, or about a 14.7% chance of getting exactly 6 shots, right? Maybe it's the first 6 he makes, maybe it's the last 6 he makes, maybe it's spread across the entire 8 times, but we know that in order to get exactly 6 shots, it's about a 15% chance. What if I want 3 or fewer, though? Well, if I want or less, that's a CDF problem. So it's going to be binomial CDF. And then, again, it's going to be 8 tries, 80% chance to make it. But I want 3 or less, so I'm going to put a 3 in here. Because what this does is it basically does this. It does the binomial PDF for 0, 1, 2, 3, and then adds them together. But rather than you doing that yourself, the calculator will do that for you. So distribution, we go down to binomial CDF, which is right there. Again, 8.83. And we get 0.010. So 0.010, or roughly a 1%. So there's a 1% chance that he makes 3 or fewer shots, which again might seem odd, because you think, okay, well, missing 3 shots shouldn't be that hard. Well, you're right, but he's not aiming to miss 3 shots. I mean, he has an 80% chance to make it. So the chance he only makes 3 or less is going to be pretty small, because an 80% chance means you're going to be making most of your shots, right? And 3 is less than half. So, again, CDF means you're going to include the number at the end. Same exact format, just a CDF instead of a PDF. Now, here's the tricky one. 5 or more. So 5 or more. So then you think to yourself, okay, this is still a binomial CDF problem, but it's not just going to be binomial CDF, but we'll figure that out in a second here. So 5 or more. Let's say let's put our 5. We have 1, 2, 3, 4, 5, 6, 7, 8. I want the chance that he gets from 5 or above. I want the chance that he makes that anywhere in this zone here. So I want to get rid of 1, 2, 3, and 4. So what I do is I do a binomial CDF of 8.8 and 4. That will get me all of these stuff right here, right? Binomial CDF of 8.8 and 4 will get me all of this probability. And then I'm going to subtract that away from 1, because 1 is the chance of everything. These entire sets of probabilities here is 1. If I take off 1, 2, 3, and 4, that means I'm just left with 5 or more, which is exactly what I want. Now, sometimes this will be 4, sometimes it might be 5. Sometimes you might include the exact number on there. If I said I want the chance that he makes more than 5 shots, that means I don't want to include the 5. That means I want to get rid of it. But here I say 5 or more, which means that having the 5 is okay. So I'm going to go to my calculator once again, and I'm going to subtract 1 minus the distribution of the CDF of 8, comma, 0.8, comma, 4, not 5, because I want to keep the 5. I want to get rid of, subtract 4 on down, which gives me 0.944, we'll say. So about a 94.4% chance. Okay? So when you're doing a more than problem, always be careful about how they phrase it. 5 or more means keep the 5. Therefore, you're going to put it in a 4 because you don't want to subtract off the 5. If I said more than 5, then you subtract off the 5 because you don't want to keep the 5 in that case. So read the problem carefully, right? But these are the 3 basic problem types for a binomial situation. A Poisson is very similar, except that instead of tracking a number of trials, we track it over a period of time or distance. I'll put DIST for short. So time or distance. We don't track it for a set number of trials. You're not like trying something 10 times or 20 times or 50 times. You're simply tracking it over the course of an hour or over an area of 20 square miles, something like that. So it's more for continuous. I probably misspelled that, but it's more for continuous data because remember, continuous data is like time or distance. You measure time and you measure distance. Whereas binomial is more for discrete data because you count the number of free throws they attempt. You don't measure the number of free throws they attempt, you count them. Here we're measuring. So a Poisson only has 2 values to be aware of. The first one is mu, which looks like this, Greek letter, which is the average. That's all it is. It's just the average. And then x is the I guess you could say the number of wins again. So x is the number that you're tracking. X is the number that you want to find. The probability for the number that you want to find. And the standard deviation is just the square root of the average. So if you root mu, you get the standard deviation. There's really no other trick to that because you only have 2 values to work with anyway. So there's no n, there's no p, and there's no q. It's just mu and x. And the thing is that you have to get your average sometime yourself. And the way you get your average is that the time or the distance value should always be on the bottom of the fraction in most cases. Because your average is tracking, some number over time or distance. Right? So if I say, well, let me show you the exact problem here. Let's say we have a salesman. He sells 80 items over the course of 30 days. Well, that means in order to use a Poisson, I need to figure out how many items does he sell in one day. So if I want the average items of sold per day, I want the number of items he sells divided by the number of days it takes for him to sell them. That will get my items per day, right? So 80 divided by 30 would give me 2.67. Because it's 2.6 repeating. Let me do a mic check here, which it still is on. Give me 1 second here. All right, so I had to readjust my mic there because I think it was about to go out. So 2.67 is my average number of items sold per day. So this is my mu, right? Again, my time goes on bottom. The number of items I have, or the number of things I'm tracking, is what goes on top. Now, if I want the probability that he sells exactly 4 items in a given day, so Monday, what's the chance that he's going to sell exactly 4 items? Well, that's an exactly problem, so it's still a PDF. We still use the PDF and CDF stuff here, but it's going to be a Poisson PDF of my average and 4, right? On average, he sells 2.67. I want the chance that he sells exactly 4. So we're going to go to distribution again. We're going to go down to where it says Poisson, PDF, and we do 2.67, comma 4. And we get about, again, a 15% chance or so. So 0.146. I think it was like 1.66. We'll do this as 0.147. We'll round correctly here. So about a 14.7% chance. Okay? So Poisson PDF, Poisson CDF work the exact same way as binomial. It's just that you have the average to look for, not the NP and X. What's probability sells at least 5 items? So this is with you a little bit of mental thinking here, right? At least. So at least means I want to be 5 or more, right? At least means no less than 5, right? So this is 5 or above. So that means I want to take away everything from 4 on down. So this is going to be another subtraction problem. Binomial CDF of 2.67, comma 4, and then subtract that away from 1, right? Because once again, I want to subtract off everything I don't want. So at least 5 means I want to keep the 5. So I put a 4 in here. So when you're doing this, ask yourself, what do you want to keep? What do you want to take away? So 1 minus the distribution of Poisson CDF 2.67, comma 4. Again, make sure you're using CDF, not PDF here. So we get about 0.133, right? So 0.133, or roughly, like I said, 13.3%. So that's the chance he's going to sell at least 5 items. So maybe 5, maybe more, but at least 5. Now, if I want the probability that he will sell less than 3, so less than 3 means I don't want to include, I want 2, 1, or 0, right? Less than 3 is 2, 1, or 0. So I'm going to do Poisson CDF of 2.67, and not of 3, but of 2, right? Because I don't want 3 items. I want less than 3 items. So I'm going to put a 2 in there instead of a 3. So I'm going to go to my value here. So the Poisson CDF, let me erase that one there, of not 3, but 2, right? And that's going to give me about a 50% chance. So 0.5. Well, I did everything else to the 3 decimal points. Let me make sure I'm consistent here. So 0.501. So that's about a 50.1% chance, which again makes sense because my average is 2.67. So this is pretty close to my average. Remember, the average is theoretically where there's a 50-50 split. So this is theoretically pretty close to my average. And since it's a little bit less, it's not going to be exactly 50. But again, that's why. If he sells, on average, he sells a little bit more than 2. So therefore, it's going to be a little bit above 50% if he wants to sell 2 or fewer. So again, exactly, if I want to sell less than 3 items, that means I don't want to include the 3 in my CDF. I just want from 2 on down. Not 3 on down, but 2 on down. So always ask yourself, what do you want to take away and what do you want to keep? In this case, I want to keep everything. I want to take away the 3 essentially and just keep the 2, the 1, and the 0. So there's no subtraction needed because I'm not subtracting off from 1. I'm not going bigger than. But I want to make sure that I don't include the 3 in my formula. So again, the tricky part about this is not doing the math because the math is all done in the calculator. It's just knowing what value to use and when to use it. And then obviously knowing PDF or CDF. All right, so let me, again, make sure my mic is still on here. It's important to know the difference between Poisson and binomial too when it comes up. So remember, a binomial is when you have a set number of trials. So again, if you're trying, 8 free throws, or you're flipping a coin 10 times, or you're picking 5 people, whatever. If you have a set number of trials, it's a binomial. If you're tracking it over a period of usually time or distance, then it's a Poisson. Basically, if you can't find an n, it's Poisson, right? Because the n is usually one of the easier numbers to find. How many times are you trying? If you can't find that, it's probably a Poisson distribution. It's like here. What's the probability you'll get 8 questions right on a 10-question quiz? Well, 10-question quiz means you have 10 tries to get a question right? You have 10 different tries you're going to be doing, right? Well, that's going to be a binomial because you have 10 different tries. You have a set number of trials, 10. 10 questions to answer. What's the probability to get struck by lightning 3 times in one day? Well, again, here we're talking about a day. We're tracking it over the course of days. So that's going to be a Poisson. So 3 is not your n. 3 would be like your x in this case. That's the number you're tracking. But what you're testing it over is the course of time or the course of a day. So therefore, it's going to be more Poisson because you don't have an n. You don't have a set number of trials. It's not like what's the probability to get struck by a lightning after 5 times? Well, what's a time of trying to get struck by lightning? There's really no time of trying to get struck by lightning. There's no way you can quantify that into an instance. So you track it over the course of a period of time, or days, or years, or months, in this case days. And that's what makes it a Poisson, is because you're tracking it over a period of time, not a set number of specific tries. All right, so that concludes this video here. Hopefully this helped you out. I know stuff like this and like these were the ones that kind of tripped us up last time. So make sure, again, you get used to tracking and asking yourself, which numbers do I want to include in the PDF and CDF, and which numbers do I not? Okay? Always ask yourself that question before you tackle a problem. Hope this video helped you out. Have a good day.